All right, so this is lesson 4 in measurement. And this one, what's nice is it is essentially the exact same process that we've used for both metric and for imperial stuff. But this time we're talking about capacity and mass. Okay, so before we were talking about length, so how you're measuring how long something is, right? You're talking about feet and inches or miles. And then in metric, you're talking about meters, kilometers, millimeters, things like that. Now we're going to talk about capacity, meaning like volume, as in how much can something hold. Okay, so like a can of pop can hold normally 355 milliliters. I think is the standard, right? So how big is a container? That's what capacity is talking about. So for metric, it's nice and easy. It's just different kinds of liters in the same way that meters works for metric. Um, and then uh, like before, for the imperial system, there's a whole bunch of different things like ounces and cups and etc. Okay, and then we'll also do mass. Okay, when we say mass, it's like how heavy something is. Okay, how much material is something made of. This is where we talk about kilograms and pounds and things like that. So let's talking about weight. So if you see mass, it's talking about weight, which is on your formula sheet. It says mass, and also in brackets it says weight. So same process, just different types of measurements that we're talking about. How much can something hold and how heavy is something? So to start off, we're just going to do some metric examples. Okay, so this here is now talking about liters and milliliters instead of before we were talking about meters and millimeters. This L is kind of, we've replaced our M with an L for liters. Okay, so on your formula sheet, you have the metric staircase. I've just copy and pasted it over here for the sake of this video. It's not actually on your sheet, but I'm just going to put it here so you can kind of see the process. So in this case, we're starting at liters and we're going to milliliters. Okay, so liters is our base unit. There's no letter attached to it or anything. Before we used to have meters here. Sorry, let me get off that. There. Before we used to have meters as our base unit. Meters. Okay, now instead of meters for length, we're going to talk about liters. So it's going to go right here. Liters is now our base unit. Okay, and we write just an L for liters. So I'm just going to write an L here. That's our basic unit. And then all the other units are either 10 times smaller or larger, starting with this L, right? So then 10 times smaller than a liter would be a deciliter. So we'd write that as DL, right? D for deci and L for liter. 10 times smaller than that is centiliter, and then all the way down to milliliter, which is what we're more familiar with. And then going up, we have deciliter, so that's DAL, hectoliter, and then kiloliter. Okay. So as our units get smaller, we're going to need more of them to measure the same amount. Okay, so 1 liter, if you think of like a 1 liter jug of milk or something, okay, 1 liter, it's about something like this. If you can see my hands, there we go, yeah. So 1 liter is about like this kind of amount of space, or you think of 1 liter jug of milk. If we want to say how many milliliters is in that, okay, these are 1,000 times smaller than a liter. Okay, so we're now talking about very, very small units, and so we need a lot of them in order to talk about the same amount. So I said how many milliliters is in 2 liters. It's going to be a big number. So using our staircase, the way we do this is we say we're starting at liters, and then we need to go down to milliliters. So every step we go down the staircase, 10 times smaller unit, 10 times smaller, 10 times smaller. Every time we go down a step, we're going to multiply by 10, just like we did with meters before. Okay, so times 10, times 10, times 10. Okay, you cannot say times 30. That is not going to give you the right answer because 10 times 10 times 10 is not 30. It is 1,000. Okay, so if you put what you would need to put into your calculator would be 2 times 10 times 10 times 10. Okay, and that is going to give you 2,000 milliliters. Okay, and we would put that here. That would be our answer. 2 liters is the same thing as 2,000 milliliters. If we went 3 kiloliters to liters, okay, I'll just kind of erase my work up here. Oops, went a bit too far there. Okay, I'm just gonna use a different color pen instead. Okay, this time we're starting at kiloliters all the way up here, and we're going down to liters. This is again 1, 2, 3 steps down. So that'd be times 10, times 10 times 10 for each step. Okay, so this is again multiplying by 10 3 times. Okay, 3 times 10 times 10 times 10. So this ends up being 3,000 liters. Going the reverse way, yeah, I'll do this example here. Going the reverse way, you're dividing by 10. Okay, so this example starts at decaliters and goes up to kiloliters. Right, so this example starts at deca and goes up 2 steps to kiloliters. Use blue here. Up 1, up 2. Okay, so if we're going up, for every step we go up, we're going to divide by 10. Okay, bigger units, we need less of them. So this one, we went up 2 steps, so we'd say 620 divided by 10 divided by 10 to get 6.2. Okay, and that's it for metric. Okay, it's the exact same system. If we're talking now about the imperial system, they have all kinds of different conversions that we have to use. So you will want to get a bit familiar with what these different abbreviations mean. So FLOZ, okay, it means like fluid ounces. These are all on your formula sheet, and most of them are written there. So, but every once in a while you'll see one that you're not sure and you need to kind of check. So if this one says, if we have 8 cups, okay, C stands for cups, how many fluid ounces would that be? Okay, and it specifies US ounces because there's different kinds of ounces in the US than there is in the UK. So 8 cups is how many fluid ounces in the US. So we look at our imperial units. This is on your formula sheet, all this information. So you would be given this on test. You don't need to memorize this. But 1 cup is the same thing as 8 fluid ounces. Okay, so like 1 cup is 8 fluid ounces. Okay. So if we had 2 cups, it would be 16. 2 cups would be 16 fluid ounces, and 3 cups would be 24. Okay, because every cup is just adding 8 more. So all we're doing to turn cups into these ounces is just timing by 8. So if I want to know how much 8 cups would be, I'd say 8 cups times 8 will give me my fluid ounces, which is then 64. Okay, so 64 would be my answer here. Next question says quarts to gallons. Okay, so quarts to gallons, I need to find what's the relationship between quarts. How many quarts is there in a gallon? So I look on here and I find, okay, quarts, but I don't have a conversion here that goes from quarts to gallons. I have one to pints, I have one to fluid ounces, but not there. Okay, so then instead I'm going to say, what about gallons? Okay, where's gallons on here? Gallons I can turn into quarts, or I can turn them into fluid ounces. Okay, we want this one here going, what's the relationship between gallons and quarts? So 1 gallon is 4 quarts, right? So let's say this is 1 gallon. 4 quarts makes up 1 gallon. Okay, so we would need 1, 2, 3, 4 quarts to make up 1 gallon. Okay, so every 4 quarts is 1 gallon. So I'm starting here with this unit, 4 quarts, and going down to gallons. Okay, in this case, I'm starting with 4 and going down to 1. 4 quarts would be 1 gallon, 8 quarts would be 2 gallons, 12 quarts would be 3 gallons, and so on. Each time I'm dividing by 4 is what I'm doing here. Okay, so 10 divided by 4 is what's going to give me quarts to gallons. Right? And what I end up getting is 2.5 gallons, which makes sense, right? If 4 quarts is 1 gallon, then 8 quarts would be 2 gallons, and then another 2 is just another half of a gallon. So as far as imperial stuff for this, it's just a matter of looking on these relationships between the conversions, like how many quarts is in a gallon, right? Finding there, and then finding out, am I multiplying or am I dividing? Anytime you're starting with the 1 and going over to another number, you just need to multiply by that number. Okay. If you're starting with a number that's not 1, like here we're starting with 4 and going down to 1, that's when you need to be more careful. Okay, 4 to 1, now we're having to say, how do we get from 4 to 1? We're dividing by 4. Okay, so I'm going to go quicker through this because this is exactly what we did in the first part of the lesson. So now we're talking about mass or weight. Okay, Here it has our metric staircase. This is filled in for meters. But if we wanted to do grams instead, we would just replace all of these m's with g's. Okay, instead of an m there, our base unit is now a gram. Okay, this is a gram. So then going down, we would have decigrams and centigrams and milligrams. Going up, we'd have decagrams, hectograms, and kilograms. Okay. But the process works the exact same. 18.4 kilograms to grams. We're starting with kilograms and going down to grams. 1, 2, 3 steps down. Each step down, we're multiplying by 10. Right? Times 10, times 10, times 10. So this just becomes 18.4 times 10, times 10, times 10. So 18,400. This example goes from a small unit to a big unit. Okay, in this case, we're starting down at milligrams and going up to grams to here. So 1, 2, 3 steps up to go from milligrams to grams. As we're going up, we're dividing by 10 for each step. So divide by 10, divide by 10, divide by 10. So 750 divided by 10, divided by 10, divided by 10. And that ends up giving us 0.75 grams. You could have a 0 here if you want, but it doesn't matter either way. It's the same number. And then very last is how do we measure weight in the imperial system? And it's the same process of converting between all their different weird units. Okay, the ones that are going to be tricky is you'll see that they have like a fraction here for some of them. So this means like 2.5 pounds. When it says you want this to be a decimal, not a fraction. Okay, 2.5 pounds means 2.5 pounds, right? If it was 2.25 pounds, right? A quarter is like 25 cents, right? Or a quarter, so it'd be like 2.25, right? 2.75, think of it as like 3/4, like with money, right? 3/4 would be 75 cents. It works the same here. 3/4 would be 2.75. Okay. If you think of it as like in terms of money, it can help you figure out what those decimal numbers are. Think of it as like $2.25. That'd be $2.25, or $2.75, right? That'd be $2.75. So if you're not sure though, like there's some that are a bit weird. Like sometimes you'll get one that'd be like 2 5/8, right? Because the imperial system has to be difficult. If you're not sure, what you would do is you just take 5 divided by 8 in your calculator, and that will give you the decimal that goes after this 2. Okay. So 2.5 pounds to ounces. Okay, so we're going to find what's the relationship between pounds and ounces. 1 pound is 16 ounces. So if we're taking pounds and going to ounces, what we're doing is to get from 1 to 16, we're multiplying by 16, okay, times by 16. So we're just going to say 2.5 times 16 will tell us how many ounces we have, which is 24. Okay. The only other thing that is in here is just then converting between imperial and metric. Okay. The easiest way to do this is it has like imperial to metric and metric to imperial. Figure out what your units are. What are you starting with and going to? Okay, in this problem, how many pounds are there in 2.5 kilograms? We're starting with 2.5 kilograms and then going to pounds. Okay, so kilograms is metric. Okay, that's where we use our staircase. Pounds is imperial, the American system. Okay, so we're going from metric to imperial. The easiest set of relationships to use then is the one that says metric to imperial, starting at metric, going to imperial. Because this will have your values starting here with your metric. So we are going from kilograms to pounds. So we find kilograms, and we need to convert it to pounds. 1 to 2.21. If you have a 1 here, you are going to just multiply by the number on the other side. Okay. To get from 1 kilogram to 2.2, we're just multiplying by 2.21. So 2.5 kilograms times 2.21 pounds in a kilogram, but 2.52 times 2.21 is equal to our final answer. And yeah, that's where I'm going to stop here because it's really, this is all the same stuff. Okay, this is same thing, but with now volume instead of mass. So hopefully that gives you enough to get started on this stuff or to do the practice problems and get as much done as you can. And I'm always available for help when you need it. So good luck.